Hello guys, welcome to Crown Smart. In this video we are still going to be talking about limits. Now in our previous video we discussed about limits of a function and I explained what a limit is and I gave also beautiful examples there. So also we are still going to continue from where we stopped. I still have more examples to solve, so I would like you to follow me while solving this. Please pay attention while I'm doing this. Now just like the same way we did your previous one, we are still going to solve this one the same way. So we want to solve the following. Now the limit of this is a rational function. We want to solve this rational function as x tends towards 1. We want to see what this function will, the value which this function will approach, okay, as x is approaching what? 1. Okay, x approaching 1 doesn't mean that x is equal to 1. It's x keeps going towards 1. Okay, it approaches 1. It's not actually it's 1. Okay, so let's solve this by what? Substitution. So solution. So our first one is the limit as x tends to 1 of the function x squared minus x plus 2 all over x cubed plus x squared minus 2. Okay, so now anywhere we see x here we put what? 1. So this means that we have 1 square minus 1 plus 2 all over 1 cube plus 1 square minus 2. Okay, so this is equal to 1 square is 1, so 1 minus 1 is what? 0, so we have 2 all over 1 cube is 1 plus 1 square is 1, so 1 cube plus 1 square is 2. Now 2 minus sorry, that's not 2, sorry, my bad, that's 3. Okay, so that's 3. Let's correct ourselves. That's 3. So this is 1 cube is 1 plus 1 square, that is 2. 2 minus 3. So this is equal to 2 all over 2 minus 3 is minus 1. So this is equal to what? Minus 2. So that's the limit of what? This function. Okay, so it means, let's say this is 1. Now let's say these are values of x from the positive part, x from the negative part. Okay, so if we keep putting all those values, let us say if we put 5 in that function, you see that the value is approaching 1. If you put 4, if you put 3, if you put 2, if you put 0.1, all those values, not 0.1 actually, 1.1, you see that those values keep what? Approaching what? Minus 2. The same way if we come from the left, if we take those possible values of the left, keep imputing those values to the left, we see that the value we are getting is what? Approaching what? Minus 2. So now we now solve for the second one. The second one says the limit of f of x, limit of what? F of x minus f of 3, okay, all over x minus 3 as x tends to what? 3. Now remember, they say where f of x is the what? Square root of x. So this is equal to what? F of x is what? Square root of x from the question. Square root of x here. Where your f of x is what? Square root of x. So now if my f of x is square root of x, now what is my f of 3? Remember in our previous video where we did something like this, where we say whenever you have f of x to be something, let us say x squared, so your f of 2 will be, anywhere you see x, you put what? 2, so this will become 2 square. So that's what we're going to do here. So our f of 3 is simply what? The square root of what? 3. Okay, now this is going to be all over what? X minus what? 3. Okay, so now we substitute. Okay, sorry, I made a mistake here. I was supposed to put the limit as x tends to what? 3. Okay, so we then substitute the value of x here. So we have this as the limit at x tends to 3 of the square root of what? X minus square root of 3 all over x minus what? 3. So if we substitute the value of 3 by substitution, we have root 3 minus root 3 all over what? 3 minus 3. This gives us 0 over what? 0. So this is another indeterminate what? Case. So what we are going to do is we are going to simplify what? The question. We're going to simplify this. So we simplify it. How do we simplify it? Now root x minus root 3 all over x minus 3. Just like we did in our previous video, we're going to multiply this by its what? Conjugate. Okay, multiply both the numerator and the denominator by the conjugate of this numerator. Okay, so we have this as now remember, this looks like our difference of what? 2 square. So this becomes root x all square minus root 3 all square all over x minus 3 times root x plus root 3. Okay, so this is it. Now this is equal to, the square will cancel this square root, so we are left with x minus this square cancel this, we are left with 3 all over x minus 3 times root x plus what? Root 3. Okay, so this cancel this, we are left with what? 1 all over what? Root x plus what? Root 3. So therefore, remember, we simplified the whole of this, okay, to give us this. So therefore, the limit x tends to 3 of the function root x minus root 3 all over what? X minus 3 is equal to the limit as x tends to 3 of what? 1 over what? Root x plus what? Root 3. This thing you are seeing here is the same thing as this one, so they are all the same. We just simplify this to get this. So we can now evaluate the value of 3. This is equal to 1 over root 3 plus what? Root 3. This is equal to 1 over 2 root 3. So this is root 3 plus root 3 is 2 root 3. Now we can rationalize this. We can't leave our answer like this, so we rationalize this. How do we rationalize this? We multiply both the numerator and the denominator by root 3. So this gives us root 3 all over 2 root 3 all square. So this is equal to root 3 all over what? Now this cancel the square, so we're left with what? 2 times 3. This is now root 3 all over what? 6. Okay, so that is our answer. So now we move on to the last one. We have that the last question says the limit of f of x minus f of c all over what? X minus c as x tends towards c, where f of x is what? Your f of x is defined as 1 over x, and your c is any number in the domain of f. So c is any number that makes this function, okay, defined. So any number that makes this function defined is your c. So now we want to find the limit of this function. Now our f of x is 1 over x, so we have the limit as x tends to c. Okay, your f of x is what? 1 over x minus, now if f of x is 1 over x, therefore my f of c is simply what? 1 over what? C. Anywhere I see x, I put what? C. So this is minus 1 over c all over x minus what? C. Okay, so we're going to simplify this. So this gives us okay, let's substitute this first and see what we get. Now if I put c here, this gives me what? 1 over c minus 1 over c all over c minus c. This gives me 0 over 0. So this is an indeterminate case. So what we are going to do, we're going to simplify this and see what we get. So since this gives me an indeterminate case, we are going to simplify this to see what we get. So we have that 1 over x minus 1 over c, okay, divided by x minus c. So what's the LCM here? We have this as what? xc is the LCM. So a simple way of doing this is c times this will give me c minus x times 1 will give me what? X, okay, all over x minus c. What I just simplified now, I just did this one. I solved for this and I got this, okay, using your LCM method, and divided by this. So this is what we got. Now remember, this thing you're seeing is just a single value divided by this. Now I want to emphasize on this, like I want to clarify, because most students get confused with this. Whenever you have a question, let's say you have a over b divided by c, okay, the best thing to do is simply bring down these down parts, this denominator here. So we have a over what, bc, just bring it down. Okay, also whenever you have a divided by b over c, okay, now you're having a divided by, this is just a single value, so we just simply take the down part here up, so this becomes what, ca over what, b. So take note of this. It's just a short way of beating time. So whenever you have this kind of thing, you are sure that this is dividing, that is this divided by this, simply bring this one down. And whenever I have a divided by just this, simply bring this one up. So this becomes ca over b, and this one becomes a over bc. So that's what we're going to do here. So observe that this is just like this one, so we're going to bring this one down. So we're going to have c minus x all over xc, okay, times x minus c. Now observe that we can simplify this up. I can multiply both the numerator and the denominator by minus 1, okay. So I'm multiplying up here by minus 1, multiplying down here by minus 1. It doesn't change anything. You know why? Because if I cancel these two, I have 1 times this still maintains this question. So this gives me what, if I multiply here by minus 1, I have x minus c all over minus xc, okay, x minus c. So this cancel this, I'm left with what, 1 over what, minus xc. Now if we have a case where we have 1 over minus 2, this is the same thing as minus 1 over 2. So 1 over minus xc is the same thing as saying minus 1 over what, xc. So we can now put this thing here. Remember, this answer we got here is the same thing as this, okay. So we have this as the limit of 1 over x minus 1 over c all over x minus c as x tends to c is equal to the limit as x tends to c of what, minus 1 over what, xc. So this is equal to, by substituting it, we have minus 1 over what, c square. So this is our final answer. Thank you very much for watching this video. Please do not forget to subscribe, watch and like it. Also share to your friends. Thank you.